By the way, here we are now after finding our function. Finding our function is the hardest part, and definitely all the hard work is done, and it might seem like that takes forever to do. Well, it does take a while to explain, but once you do that a few times, it really is like a 30-second process to find, to go from all the way from what we did, what took me 11.5 minutes to explain, it really can be done in about 30 seconds. Once you know where all the numbers go and you're familiar with Newton's law of cooling, it really is a pretty quick process. So anyway, 30 seconds to a minute after you read this problem, you would get to right there. Okay, so then it's important, I wrote this down here before I started obviously, but just wanted to remind you that at t equals 0, at the beginning, t equals 0, that's when the temperature was 70 degrees above. Now is, we're actually at t equals 20 and we're calling that now. So keep that in mind because that affects all the other numbers. What we're trying to figure out here for part A is what is the temperature going to be, how far above room temperature will it be 15 minutes from now. Okay, so if now is t equals 20, then you should be thinking to yourself, what am I actually trying to find? I'm trying to find the temperature at t equals, very good, I'm sure you said to yourself 35 because that's 15 minutes from now. Okay, so we want to find the temperature at t equals 35. And that is really easy because we just type it in. We already have our function and the t value is 35. And so when you type that into your calculator, I don't know if we're going to be able to do this all here. Might as well. Okay, so we can kind of squeeze them both in there. 70 multiply, let me clear it out. 70 times e to the 35. Oh, I didn't, darn it, I didn't store my a, so let me do that really quick. Ln of 6 over 7. Okay, I'm totally chunking here. Ln of 6 divided by 7, and we're dividing that by 20, and I'm storing that in alpha a. Gosh, man, I guess I'm no excuse. All right, there we go. So there's our there's our k. And again, storing that in alpha A, enter. So I can just use my alpha A when I want that K. So I have 70. Can you see that? All right. 70 times e to the 35A, which is our K. Stored it there. And we get 53.449. And so that is, let me move that over, 53.449. So we get approximately equal to 53.449. And you always need to ask yourself, what is that number? Okay, what's temperature? Temperature then would be degrees Celsius, and again above room temperature. Okay, so that's where we're at. 2 hours from now, go ahead and pause the video and come back and see if you get the part B right. In fact, you can probably do parts B and C. Now, after seeing that, I encourage you to try that. I'm going to go ahead and put a box around this and then just come on right back and then figure that out. Pause the video, come right back. Okay, so 2 hours from now, you should have indicated that you wanted to find hours. Now, remember, you got to convert to minutes because we're talking about minutes. Our function is in minutes. Y of t equals 70 e to the k t, and so 2 hours would be 120 minutes, and again the now is at t equals 20, so we really want to find y of 140. So good job, I'm sure you did that. 70 e to the k times 140, and what you should have gotten is 23.794 degrees Celsius above. I can just say it above room temperature. Okay, and then part C. Moving on out here so we can see it better. Let me readjust. Well, here we finally have to do a little bit of work. Can't just plug it in and write down the equation and plug it into the calculator. Do a little work here. So that's we want to find T. Okay. Challenging you again to pause the video if you didn't do that. If you haven't tried C yet, please go ahead and do that. So we're trying to find T. When will the silver be 10 degrees above? So we want to find T when y of T is 10. Okay, so again, y of T is 70 e to the k times T. And we are going to just let y of T be equal to 10. And we solve this equation. K times T. Now this is, in this equation, we don't know what T is. So we put that there. We're going to divide both sides by 70. Now, please don't ever try to convert this to logs without getting that e in the front. We'll get the e right in the front, meaning you don't want any coefficients in the front there to spoil the show. 10 over 70 is just 1 over 7. Now we are in a position, I'm sorry, it's just a habit. If you're bothered because I keep putting a box around that, it's just a habit. I don't know if I can break that. But anyway, we're going to go ahead and take the ln of both sides. I've been doing that in green, so I'll continue to do that. So we have ln of both sides, and we get ln of 1 over 7 equals k times t. See how important those solving log and exponential equations was in the very beginning? Okay, and so here we have t is equal to log of 1 over 7 divided by k. If you just plug that into your calculator, you would get... Oh, so when you get t, you're going to get a 252. Now you got to be really careful. You have to be thinking here. Always got to be thinking. Okay, so if you're... Hold on. Sorry, I need to scoot this out a little bit. Alright. Technical difficulties. Let's make sure you're good. Okay. The t value, remember, if you do remember this, we had when t equals 0, that was when we had a 70 degrees. T equals 20, that was a 60 degrees. But again, that was the now. Okay, that was now. And what's asking, when will the silver be 10 degrees Celsius above? Okay, well, from now, it won't be 252 because the 252 is from t equals 0. T equals 0, you go 252 there. Okay, that's 252 minutes. But from now, you got to subtract 20, right? So you subtract 20 and you get 232. So from now, we get 232.469 minutes. That's how long it's going to take. And so I suppose we could just kind of write that as therefore 232.469 minutes from now. And there you go. That is Newton's law of cooling. I just want to let you guys know. I was looking for some trivia or something interesting to share with you on Newton's law of cooling, and I found this really cool website that you actually have to solve this mystery. That you're a detective. I put a link to that. If you go to the calendar, and I think I put it on today's date, so the 8th, November 8th calendar, click on Chapter 6 Resources or something like that. Chapter 6 Test Study Guides or something. There's a link in there. Click on the link and you can actually read the problem, and you can actually use Newton's law of cooling to determine the time of death given the scenario. And I did it, and I used Newton's law of cooling. I actually got it right, and I challenge you to get that right. If you could get that right, you could get any of these Newton's law of cooling problems right. So there you have it. Have a great night, and I will miss you guys tomorrow. I hope you have a great day and a great 3-day weekend. I will see you next Wednesday.